All right, guys, welcome back. And today we are going to be going into 5.2, which is trigonometric ratios in right triangles. And just for a think slash warm up, I'm just having us recall the Pythagorean theorem because it's going to be useful. So just in case we forgot, even though it's one of the most popular theorems out there, when we have a right triangle and we have two legs A and B and a hypotenuse C, then we have a squared plus b squared equals c squared, and that is referring to the side lengths. So, a little bit of words here. In a right triangle, one of the angles measures 90 degrees, and the remaining two angles are acute and complementary. We know this. A right triangle has a right angle in it, and complementary, remember, means that two angles add to 90 degrees, and since a triangle is 180 degrees, and if a right angle is 90 degrees, and that only leaves 90 degrees, so they have to be complementary. And then we have the hypotenuse, which is alongside, always going to be across from the right angle, and the other two sides are called legs. The ratios of the sides of the right triangle can be used to define trigonometric ratios, and they are called sine, cosine, and tangent. And I have this mnemonic here that we may have already heard maybe in an earlier class, SOHCAHTOA, which is going to help us remember these trig ratios. So the words, again, are sine. So when you're talking in words or writing them out as if you were talking, this is how you'd write them: sine, cosine, and tangent, just how we had them before. Now, when you're writing in terms of math, like you're working on a problem, the symbol for them is going to be sine. And I'm going to put theta, and then cosine is reduced to cos, and then tangent like that. And then those still read sine theta, cosine theta, tangent theta. And theta just is what we're putting in for like an angle. It's a Greek letter. You can think of it as like x, right? We could call it x, but it's just very common in math to call angles theta. And usually x is a different variable. And so our definition is coming from SOHCAHTOA. So this means sine equals opposite over hypotenuse. This means cosine equals adjacent over hypotenuse. And this means tangent equals opposite over adjacent. And I'll write that out over here. So sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And then tangent of theta would be opposite over adjacent. And when we are talking about that, when we're talking opposite, adjacent, and hypotenuse, we are referring to sides of a triangle. And this is, definitely something you would want to write down right here. So I would pause and write down specifically this and SOHCAHTOA, because that's where it comes from. And I would write down this triangle. So whenever we are talking about a trig ratio, we're talking about in terms of an angle. So we have these thetas here. Those thetas are the angle that we are referencing, right? So if we come down to a triangle, the right triangle, and we better be talking about a specific angle theta, right? Because we could be talking about this one or the one up here. I suppose we could be talking about the 90-degree angle, but that's, not not typical and what we usually won't work with. So in reference to this angle theta, the hypotenuse is always going to be the same. The hypotenuse is always across from the right angle. And then what we're talking about in opposite and adjacent, the side opposite to the to theta is the opposite side. And then if we remember what the word adjacent means, adjacent just basically means next to. So the side next to the angle theta, that isn't the hypotenuse, right? Because the hypotenuse is adjacent, but it deserves its own name. So that is adjacent. And then we're going to do a few examples real quick with these. And I would write that triangle down as well. And just a quick note, if I put theta up here, then this side would be the opposite side, and this side would be the adjacent side. All right, example 1, find the values of the sine, cosine, and tangent for angle B. And angle B right here, I'm just going to call it theta, even though we've already called it B. Actually, since we've already called it B, I'm going to not call it theta. But that angle right there is the one we're worried about. And in order to get all these, we're going to need all the sides. So here, we're going to have to do the Pythagorean theorem to get this side. And to do that, that side, we'll call that side A. Will just be 33 squared minus 18 squared. And what we'll get for that, get the square root of 765. That is the same thing as, I'll keep writing below. That is the same thing as 9 times 85, which is the same thing as 3 square root of 85. So this side is 3 square roots of 85. And now the rest is pretty simple. The sine, so the sine of angle B there is going to be SOH, right? So TOA is what we'll always use. OH, so opposite over hypotenuse, which in this case, of angle B, opposite of angle B is 18 across from it. And then the hypotenuse is 33. And then, likewise, we just keep going. Cosine of B is going to be cosine adjacent hypotenuse. So adjacent over hypotenuse. And up here, if we look, the side that is next to angle B is 3 times square root of 85. And then all over the hypotenuse, which is again 33. And then the tangent of angle B is opposite over adjacent TOA, and that will be the opposite side, which is 18, and the adjacent side was 3 square roots of 85. And that is our answers for each of those. All right, this one's a lot of reading and it came from the beginning, but it's not that bad. Let's just get to it. So as light passes from one substance, such as air, to another one, such as glass, light is bent. The relationship between the angle of incidence, which you don't really need to know what it is, we're going to call theta sub I. The sub I just tells you that we're talking about an angle of incidence, right? I, incidence. The angle of refraction, theta. So when we're talking about angles, usually thetas, and then sub R for refraction, is given by Snell's law, which is the sine of theta sub I all over the sine of theta sub r equals n, where sine theta represents a trig ratio, and n is a constant called the index of refraction. Suppose a ray of light passes from air with an angle of incidence. So this is how we dissect a word problem like this long, right? So this, all above it was kind of just like, well, like word vomit. And this is how we dissect it. So suppose a ray of light passes from air with an angle of incidence, that's something that's unimportant, of 50 degrees to glass with an angle of refraction, angle of refraction of 32 degrees and 16 minutes. Find the index of refraction of glass. Oh, and this will probably help us out here, that equation right there. So with all of those things, I underline that as important. So we're finding the index of refraction. What is that? N. N is the index of refraction. Okay, so I know we're looking for N there. So we're looking for N. And we're saying that is sine theta sub I all over sine theta sub R. And it gives us theta sub I 50 degrees, right? It says angle of incidence, which is this is 50 degrees. So we have sine of 50 degrees. And then on the bottom, the angle of refraction is going to be sine. And then in for the refraction angle, we have 32 degrees and 16 minutes. I'm probably going to want that in degrees. So we should do 16 times 1/60th, or just divided by 60, and that'll get us 0.2227, right? Or I don't know if that's whatever. So 2227. Let me just make sure that is correct real quick. 26. Sorry. So it's 26667. Okay. So now we can put 32.26667. When rounded there, it's actually 6 repeating. And then all we do is plug that into our calculator. And I think it's easier to plug each individual one in to your calculator. And once you do that, you should get roughly 0.76604, and we'll leave it there. It goes longer. And then on the bottom one, you will get 0.5338. 5338. 605. Right? And then that comes out to be, once you punch those numbers into your calculator, 1.4349. It goes longer, but I'm not going to go that crazy long. And that's N, right? That's what we had up here the whole time. That looks like an H. N. Okay. And so that's our answer for that one. So it's really just plugging what we need to know. My tip for this is make sure your calculator is in degrees. Some calculators might be in radians. Make sure you go into your settings and make sure it is in degrees. It'll be called mode on your calculator. But that is all for today. If you have any questions, as always, email me or bring questions to class or to your live Zoom meeting.